Because Google has 7 services with more than a billion users, you can bet security is always on the minds of Google's employees. Design for security is pervasive throughout the infrastructure that GCP and Google services run on. Let's talk about a few ways Google works to keep customers' data safe, starting at the bottom and working up. Both the server boards and the networking equipment in Google data centers are custom designed by Google. Google also designs custom chips, including a hardware security chip called Titan that's currently being deployed on both servers and peripherals. Google server machines use cryptographic signatures to make sure they are booting the correct software. Google designs and builds its own data centers, which incorporate multiple layers of physical security protections. Access to these data centers is limited to only a very small fraction of Google employees, not including me. Google's infrastructure provides cryptographic privacy and integrity for remote procedure call data on the network, which is how Google services communicate with each other. The infrastructure automatically encrypts RPC traffic in transit between data centers. Google's Central Identity Service, which usually manifests to end users as the Google login page, goes beyond asking for a simple username and password. It also intelligently challenges users for additional information based on risk factors, such as whether they have logged in from the same device or a similar location in the past. Users can also use second factors when signing in, including devices based on the Universal Second Factor, UTF open standard. Here's mine. Most applications at Google access physical storage indirectly via storage services, and encryption is built into those services. Google also enables hardware encryption support in hard drives and SSDs. That's how Google achieves encryption at rest of customer data. Google services that want to make themselves available on the internet register themselves with an infrastructure service called the Google Frontend, which checks incoming network connections for correct certificates and best practices. The GFE also additionally applies protections against denial of service attacks. The sheer scale of its infrastructure enables Google to simply absorb many denial of service attacks. Even behind the GFEs, Google also has multi-tier, multi-layer denial of service protections that further reduce the risk of any denial of service impact. Inside Google's infrastructure, machine intelligence and rules warn of possible incidents. Google conducts red team exercises, simulated attacks to improve the effectiveness of its responses. Google aggressively limits and actively monitors the activities of employees who have been granted administrative access to the infrastructure. To guard against phishing attacks against Google employees, employee accounts, including mine, require use of UTF-compatible security keys. I don't forget my keys as much as I used to. To help ensure that code is as secure as possible, Google stores its source code centrally and requires two-party review of new code. Google also gives its developers libraries that keep them from introducing certain classes of security bugs. Externally, Google also runs a vulnerability rewards program where we pay anyone who is able to discover and inform us of bugs in our infrastructure or applications.